All right, ladies and gentlemen, let's go through the review packet for Unit 1, the unit circle. First up, we've got 30, 60, 90 triangles. We're given the short leg right here, which means we have to multiply by 2 to get to the hypotenuse. So that will give us 18. And then to go from the short leg to the long leg, we need to multiply by root 3, and that's going to give us an 18, root 3. All right, next thing here is taking our long leg and going to our short leg. Previously we multiplied by root 3, but now we're going to divide by root 3, so that just leaves us with 2. Reason why is here we were going in this direction versus here we're going in the opposite direction. Now I need to take my short leg and multiply by 2, and our hypotenuse is 4. All right, next up we have a 45, 45, 90 triangle. So that's going to give us 2 legs that are exactly the same. And our hypotenuse is going to be 4 root 2, because the hypotenuse is root 2 times the leg. In this particular case, on number 4, we are going from the hypotenuse to the leg. So we're just going to divide by root 2, and that leaves us with 8 and 8. All right, next thing, we are going to set up trig functions. So I'm going to circle my angle z, yz, while I'm given z right here. And I'm going to label my sides as opposite. Across from the 90 is my hypotenuse, and the remaining side is my adjacent. Cosine of z, of course, is going to be adjacent over hypotenuse. So that's going to give me 40 over 50. You can certainly reduce that, but in the directions I say leave as an unreduced fraction. All right, next one here is tangent of C, which is opposite over adjacent. We are going to go ahead and circle our C because there's a C here. Label my opposite. Across from my 90 is my hypotenuse, and I'm left with adjacent. So tangent of C is equal to opposite over adjacent. In this case, 12 over 16. All right, sine of x is going to be opposite over hypotenuse. So I'm going to circle my x. Go across from my x is my opposite. Across from my 90 is my h. And I'm left with adjacent here. So sine of x is opposite over hypotenuse. In this case, we've got 10 over 26. Next up, sine z. Circle my z, opposite, across from my 90, hypotenuse, and my remaining is my adjacent. So sine of z is going to be opposite over hypotenuse is 21 over 35. All right, giving a positive coterminal angle, even if we subtract 360 here, we're still left with a positive angle. So doing that, I receive 320 degrees. So that's a correct answer. If we subtract 360 degrees again, I am left with negative 40 degrees. So there we are. We have our 2 answers. There's our negative coterminal angle. There's a positive one. And there are an infinite number of solutions here. So if you decided to just add 360 to 680, that's also a correct answer, and that gives you 1040. So any of these answers are correct. Just make sure you give me 1 positive and 1 negative. All right, next is stating the reference angle and give the quadrant it's located in. For this one, I'm going to draw the angle first. So 110 degrees is going to be starting here, going past the 90 and a little bit more. Well, what's a little bit more? Well, 90 plus 20 is going to give me 110. And then I know that this angle right here, our reference angle, is going to be 90 minus 20, which gives me 70 degrees. Okay, so for this problem here, I'm stating the reference angle, which is 70 degrees. And the quadrant that it's in is number 2. How do I remember that? This is 1, this is 2, this is 3, and this is 4. All right, taking a look at 260, I know that if I start here and I go 90 180 and not quite 270, I know that I've stopped 10 degrees short, which means I've got 80 degrees here. So 80 degrees is my reference angle because I care about from the x-axis down to my terminal side. And what quadrant is that? That is in quadrant 3. All right, moving on. So on this particular case, I need to draw my initial side, which is going to be on the positive x-axis. And then I need to figure out how to get to 535. Well, I know that if I start at 535, I'm going to make this positive just for the sake of understanding how many turns I need to do. I'm going to go ahead and subtract 360 from this. And I'm left with 175 degrees. Okay, so this means the 360 I have to do 1 full revolution. Now, what is 175 degrees? Well, that's just short of 2. So that's going to be a 90 and plus an 85. Okay, now we're ready to go. So I know I have to do a full 360. I'm going this direction. How come? Well, because it's negative. And then I know I need to go a 90, so I'm going to go one more. And then I know I have to go an 85, so I'm going to go pretty far, but stop 5 degrees short. Okay, so I'm going to have that right there, and I'm going to have 5 degrees right there. All right, next one here, 295, should be a little bit easier. You can think of 295 as 90 plus 90, which is 180. And now I'm going to do 295 minus 180, and I know I'm left with 115. Well, that means I can get another 90 out of there. Okay, and then I'm left with 25 degrees. So this is a positive angle, so I'm going to keep my initial side here. I'm going to go a 90, another 90, another 90, and then about 25 degrees. Okay, so I know that this right here is 25 degrees. Find the measure of each angle. Well, first of all, we should determine if it's positive or negative. And since we're starting up, this is going to be a positive. So there we go. That's a full 365. So, 360. And then from here to here, that's another 90. And then if this is 75, well, what's 90 minus 75? It's, of course, 15 degrees. So this little bit right here is a 15. So adding up our 360 plus our 90 plus our 15 is 465 degrees. All right. Next up here, we are recognizing that this is a negative because we just went down. Well, we have a full revolution, so that's going to be a negative 360. And then notice here that this is 80, so this here is going to be another 10 degrees. So subtract another 10, and we're left with negative 370 degrees. Okay, let's convert each degree into radians. Here, I'm going to multiply by pi over 180 degrees. I memorize this because I know the degrees are in the denominator and the degrees are going to cancel. This is going to give me negative 420 pi over 180. Well, I go ahead and I put this right here into my graphing calculator, and then I press math, and then I press frac, and that turns it into a fraction. So if I do negative 420 divided by 180, press math frac, I'm left with negative 7 over 3. And of course, I can't forget my pi. It's happening right there. My answer is negative 7 pi over 3. All right, here we go. 240 degrees times pi over 180. Again, our degrees cancel, and I'm really left with 240 pi over 180. So let's go ahead and put this in our calculator and press math frac. And I get 4 pi over 3. Well, it gives me 4/3, and I know to bring back that pi. All right, next one here is we're going to convert from radians into degrees. So here I need to have my pi in the denominator, and pi and 180 are the same. So here my pi's cancel, and I'm left with 59 times 180 divided by 36. That gives me 295 degrees. All right, next here, 17 pi over 12. I'm going to multiply that by 180 over pi. I know my pi's cancel, and this is going to give me 17 times 180 divided by 12. Let's go ahead and do that. That gives me 255 degrees. All right, we now need to complete the entire unit circle. We need to put coordinates in radians, and we're not going to use our notes. Well, let's go ahead and start with radians, and let's start with our axes. That's 0, 2 pi. This is pi over 2. This is pi, and this is going to be, let me scoot this up, maybe zoom out a little bit. This is going to be a 3 pi over 2. All right, next up, let's do our over 6, over 4, over 3, over 3, over 4, over 6, over 6, over 4, over 3, over 3, over 4, over 6. And now I'm just going to put pi, pi, pi. Then I'm going to subtract 1 and get a 2 pi over 3, a 3 pi over 4, subtract 1, a 5 pi over 6. Here I'm adding 1, so that's going to give me a 7 pi over 6, a 5 pi over 4, a 4 pi over 3, and here I'm going to give myself a high 5, and I'm going to go to 7, 11. Okay, we have all of our radians done. Now we need to go ahead and do coordinates. I'm going to start on my axes. This is the coordinate 1, 0. This is the coordinate 0, 1. -1, 0, and 0, -1. Next thing I'm going to do is I'm going to go ahead and do coordinates for the rest of them, and I'm going to take a second here and just do everything divided by 2. Make sure you're leaving enough room to put signs in there. All right, next up, we're going to write a 1 here, a 2, and a 3. And we need to square root our 2's and our 3's. Then we need to go backwards, square root of 3, square root of 2, and then 1/2. Now, I'm going to go ahead and take all my divided by 6's, and I'm going to make them this coordinate. Okay, next up, I'm going to take all my over 4's and make them root 2 over 2's. All right, last up here, I'm going to go to my over 3's, and I'm going to make those a 1 and a square root of 3 here. All right, next thing we have to do is we need to make our quadrants the correct sign. So on second quadrant here, we go left and then we go up, which is going to be a negative and then a positive. So I'm going to go ahead and put negatives on all of these. Then here, of course, we're negative, negative because we've got left and then down. So I'm going to sneak in those negatives right here. And then here we're going to be a positive and then a negative because we're going right and then down. All right, fantastic. We're done with that unit circle. All right, now I have to go ahead and find these. So cosine, of course, is the first coordinate. So cosine of pi over 6 is going to be root 3 over 2. Tangent of 3 pi over 4 is going to be root 2 over 2 divided by root 2 over 2, which is 1. Sine of 5 pi over 6 is right here. It's the second coordinate. That's a 1/2. Sine of pi over 4 is located right here. The second coordinate. That's a root 2 over 2. Sine of 7 pi over 6 is again our second coordinate. In this case, it's going to be a negative 1/2. Cosine of 5 pi over 6. Cosine of 5 pi over 6 is going to be my first coordinate here. So that is going to be negative root 3 over 2. Cosine of pi over 3. Cosine of pi over 3 is the first coordinate right here. So that's going to be equal to 1/2. Tangent of 0, I go to 0 here, and I need to do my second coordinate, 0 divided by 1. So 0 divided by 1 is 0. All right, tangent of 3 pi over 2. For this one, I go to this coordinate right here, and I'm going to do a negative 1 divided by 0, which is 0. Tangent of pi, I'm going to go to pi right here, and I'm going to do 0 divided by negative 1. That's a 0. Tangent of pi over 4 comes from this coordinate right here, and that's going to be root 2 over 2 divided by root 2 over 2, and that is 1. Tangent of 3 pi over 2 is going to be right here. That's negative 1 divided by 0. That is 0. Oop, just kidding. What is negative 1 divided by 0? That is undefined. Almost caught me there. Undefined. And cosine of 0 is going to be my first coordinate here for cosine, and that is 1. All right, folks, that's part 1 of our review packet. Come back soon for part 2.